Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are still going to continue with our topic of salt. And today we are going to be discussing on preparation of insoluble salts. So previously we discussed on different methods of preparing soluble salts, and we were able to identify which ones work best and how those processes undergo. So for today, we'll look at preparation of insoluble salts. You're just going to look at one method, and then you're going to dive deeper in writing ionic equation because this is a key part of preparation of insoluble salts. And then you're going to look at a few questions in regards to how we answer them. So we'll start with the method of preparation of insoluble salts. So insoluble salts are usually prepared by a process called double decomposition. It's also referred to as double precipitation. It still works. Both of them are mean the same. So this is done when we react two suitable soluble salt to form one soluble and one insoluble. So you see the key word there is suitable. So it needs to be the correct type of soluble salt. You're going to see later how we choose the suitable soluble salt. So an example is, for example, when we are preparing lead 2 sulfate solution, lead 2 nitrate and magnesium sulfate solution are usually mixed. So I'm going to explain to you how we choose the suitable soluble salt in a minute. Let's look at the process first. So the lead 2 nitrate and magnesium sulfate are usually mixed together, and the ions that are present in the reactant are the lead ions and the nitrate ions, and the ones that are in the reactant still is the magnesium ions and sulfate. So what happens, these two ions usually react together to produce lead sulfate and magnesium nitrate. So there is an interchange of the ions or the exchange of the anions in this case to form the white precipitates. So this is what we call double decomposition or double precipitation, because you can see when the ions have interchanged, there is a precipitation or there is a precipitate that is formed. This precipitate is filtered and then the solution is obtained, which is the filtrate. The moment we get the white solid, remember we wash it with distilled water and we dry it in between filter papers. It's as simple as that. So where the work comes in now is the formation of choosing the best soluble salt. Are you able to write the equations well, the overall equation, the ionic equation well? So we are going to use some few examples. We're going to start with the lead 2 sulfate. Let's discuss how they chose the suitable soluble salt. Sometimes you might be given the reactants to use in a question, but in most cases you're not able to be given the reactant. You come up with the reactant yourself. So how do we do that? So we want to prepare lead sulfate. So what we do, we are going to separate this into two parts. So the first thing that you're going to look for is a soluble salt of lead. And the most common soluble salt of lead we usually prefer to use, remember, all nitrates are soluble. So you notice in most of my examples, I will choose to use nitrates because the others also usually have some exceptions. So the best alternative or the best soluble salt to use for lead is lead nitrate. And then next, we are going to look at a soluble salt of sulfate. And the most suitable soluble salts of sulfate are for potassium, sodium, and ammonium. So the most common you notice me picking is between sodium and potassium. So I can take, for example, sodium sulfate. I can also take magnesium sulfate, like in the case they chose magnesium sulfate, it's still soluble, but you notice I'll keep on going back to sodium and potassium. I can go to magnesium, but also magnesium has its own exceptions later on. So we pick our insoluble salt, remember that's the first thing that we said, and then we divide the salt into two. So from lead, what is a soluble salt we can pick from lead, and then sulfate, which is a possible soluble sulfate we can use. So we will take lead nitrate and magnesium sulfate like in our example so that I can explain. So we said the first step is to mix these two solutions in a beaker and then you stir. When you stir, you notice formation of a white precipitate. A white precipitate is formed, and this white precipitate is lead sulfate. And then you filter this precipitate using a filter paper. You're going to collect it as a residue. And then the magnesium nitrate is going to be the filtrate. So after that, we do not need to heat because already it is in solid state. Our product is in solid state. So we just wash between with distilled water and dry between filter paper. So let's look at the ionic equation because this is the key part. So the first thing that you'll do, you're going to write the complete equation, how it's supposed to look like. So we said we are going to pick two soluble salts. We have already picked one of them. It's going to be lead nitrate. This is aqueous, it's soluble, plus magnesium sulfate. It's aqueous, also soluble. So there is an interchange of the anions, the interchange. So lead picks the sulfate, it becomes lead sulfate. And remember, this is insoluble, so it is in solid state. And then magnesium picks the nitrate, so it becomes magnesium nitrate. This is in aqueous, it's soluble. So you can see from the choices we picked, we are able to get the product we wanted. Next, we identify the ions both in the reactant and in the product. So for lead nitrate, in lead nitrate, the ions here are lead ions. Remember, it's still in aqueous. And then we have two nitrate ions. This means that you need to remember how the radicals look like and their valencies and charges. But since the nitrate is in bracket and there are two of them, that's why we have placed it as a coefficient here to show that it is two of them like a whole. And then plus magnesium sulfate is in aqueous, so we can break it into ions. So it becomes magnesium 2 plus. You need to remember these charges from the periodic table. The others are the radicals, and then sulfate is written like this, and it's also aqueous. When it comes to dissociating the ions, we cannot do so for solid because remember we said it is in fixed position. So the lead sulfate is going to remain as it is because it's in solid state. And then the magnesium nitrate is aqueous so we can separate the ions. So it becomes Mg2 plus aqueous plus 2 nitrates. Aqueous. So that's how we did that. Then after that, the next step that we are going to do is remove something known as spectator ions. So spectator ions are the ions that are not like this are the ions that we are not obtaining at the end of the day. Anything that we are not getting at the end of the day, like as our final product, is the spectator ions. What do I mean by that? So when we are identifying the ions, we are going to pick the ions that are different in both reactant and product. The spectator ions remain in the same state. So when you look at lead, we are starting it with it in aqueous state and it's ending up in solid state. So this is not going to be cancelled off. If we look at nitrate ions, we are starting with them in aqueous state and they're ending up still in aqueous state. This forms part of the spectator ions. We don't need them. Magnesium is in aqueous state and also in the product is in aqueous state, so we cancel it out. And then sulfate is aqueous state, but in the product is in solid state. So we do not cancel that. So whatever ions we have cancelled are the spectator ions, and they form the supernatant solution. So whatever we are remaining with now is the overall ionic equation. We just put the ions as they are to form lead sulfate. So you can see this is the final ionic equation and it will always be formed from the ions of the precipitate. Our final product is lead sulfate and we have formed it from reacting lead ions with sulfate ions. So that's how you write an ionic equation. So let's look at another example. So in case you have been told to prepare silver chloride in the lab, So let's look at silver chloride. Remember silver chloride is valence is 1. So as we said earlier, you separate these two. So we are going to look at a salt, for a salt that is soluble of silver. We said the nitrates are the best alternatives. And then the chloride, we will pick a chloride salt that is soluble. We can use sodium chloride or potassium chloride. I like using these ones because all sorts of potassium and sodium are soluble. So let's mix them too. So after picking, so we'll pick our silver nitrate. And remember it's in aqueous state because it's soluble, and our sodium chloride, which is also aqueous because it is soluble. So there is an interchange of ions that will take place. So silver takes the chlorine to form silver chloride. This is in solid state. Remember, this is our product. It's insoluble. Plus sodium takes the nitrate to form sodium nitrate. Next, we said we break this down into their ions, and we can only separate the ones that are in aqueous state. We do not separate the ones that are in solid or in liquid state. So silver, remember the ion is positive, it's 1, and then nitrate. We have done this before. Then plus sodium chloride, we can still separate this is in aqueous, and chloride ion, which is also in aqueous. When you go to the product, our silver chloride is in solid state, so it's going to remain as it is. But we can separate the ions of sodium nitrate because it's in aqueous state. Plus nitrate. So make sure you're able to get the correct charges and the correct symbols. And remember, the charges will always balance each out. You can see silver is 1 plus, nitrate is 1 minus, so they neutralize, they cancel out well. So always ensure you can see that. In the cases where we have, like you have to do a bit of some balancing, make sure you balance also the ions well. So next we cancel all the spectator ions. So silver in this side is in aqueous state, in this side it is in solid state, so we do not touch it. Nitrate is in aqueous state in the reactant and aqueous state in the product, so we can cancel this. And then sodium is aqueous state in the reactant and it is aqueous state in the product, so we cancel it, it's the same. And then chloride ions are aqueous state in the reactant, in the product, it's in solid state, so we leave as it is. So we write the remaining ions, so it is silver plus chloride ion to form silver chloride. And you will notice you're always being left with the ions that are forming the precipitate. So that also can be a clue for you to see what are you supposed to cancel out. Let's look at another question, barium sulfate. So let's pick the two salts you're going to mix. So barium, you're going to use barium nitrate. And then for the sulfate, we can use potassium sulfate in this case. So you're going to mix these two together, you stir, and then you're going to form a white precipitate. You filter it, and then you dry it between filter papers after washing with distilled water. So the ionic equation is going to be formed when you react barium nitrate, which is aqueous, plus potassium sulfate, which is aqueous, to form barium sulfate. They interchange the ions, and barium sulfate is our final answer we need, plus potassium nitrate. This is now where you ensure that your equation is balanced. The other ones, you notice they were balanced before. You can see we have 2 nitrate ions in this case, but it's only 1. And you can also see our potassium is 2 in the reactant and 1 in the product. So we need to put a 2 here, a coefficient. So that balances the equation. So when we break this into their ions, it becomes barium. Remember, it's 2 plus aqueous, plus 2 nitrate ions. There are 2 of them. As you can see, it's in the bracket, aqueous, plus 2 potassium ions also, you can see from here, plus sulfate ions. Barium sulfate is in solid state, so we do not separate it into ions. plus 2 potassium ions, you can see it, the balance coefficient, plus 2 nitrate ions because the 2 applies also for the nitrates. And then next we cancel the spectator ions. So our barium is in aqueous this side in solid, so we do not cancel. Nitrates in aqueous, it's also in aqueous, so we cancel it out. Potassium is in aqueous this side and aqueous this side, so we cancel it out. And then sulfate is in aqueous and this side in solid. So our final answer becomes barium plus sulfate ion to form barium sulfate. So that's how we form the ionic equation for different compounds, and that's how we chose the suitable salts to use for our reaction. Let's look at a few questions in regards to what we have discussed. So starting with barium nitrate. So in this case, you've already been given one of the reactant solution. Describe how a pure sample of barium carbonate can be prepared in the laboratory. So we have barium nitrate. When you look at our product is barium carbonate. So if we separate, we have already been given one of the reactants. It is going to be barium nitrate. So we have to look at a soluble salt of carbonate. We can use sodium carbonate or potassium carbonate. In this case, you're not writing the equation, we're just explaining the laboratory reaction. In other cases, you have to go to produce this carbonate, but it's still okay. So we are going to use either sodium carbonate or potassium carbonate. So we add potassium carbonate solution into a beaker containing the barium nitrate solution, and then stir the mixture to form barium carbonate precipitate. When you're not sure of the color of the precipitate, just say precipitate. You don't have to say white precipitate or that specific color. Of course, most of them are white in color, but if you're not sure, you don't have to mention the color to be on the safe side. And then filter the mixture to obtain barium carbonate as the residue and potassium nitrate as the filtrate. And then you wash the residue with distilled water and dry between filter papers. So that is a procedure for answering that question. Next question is you're provided with the following solid lead 2 nitrate. So you've already been given 2 nitrate, magnesium oxide, powder, dilute sulfuric acid, and distilled water. Describe how you can prepare dry sample of lead 2 sulfate. So when you look at lead 2 sulfate, the salts of lead we've already been given as lead nitrate. And then for the sulfate, we have been given some things. We have been given magnesium oxide and dilute sulfuric acid, which can help us to form magnesium sulfate, which is a soluble salt of sulfate. So you can see this is the reaction I was talking about. So this one requires more steps than what we have discussed before. So you are going to add excess magnesium oxide in a beaker containing warm dilute sulfuric acid and stir until the reaction is complete. And then you filter the excess magnesium oxide and you're left with magnesium sulfate solution. Then this magnesium sulfate solution is the one that you add to the lead nitrate solution to obtain lead sulfate precipitate that you filter and wash and dry between filter papers. So you see you have to take a few steps back. Sometimes, like in the first question, you can use the soluble salt already that you've chosen. Other cases, you have to prepare that soluble salt. Like in this case now, you had to prepare the magnesium sulfate because you have been given the magnesium oxide and sulfuric acid. So that's it for insoluble salt. Make sure you are able to practice on how to write ionic equation. It's the most common question in regards to preparation of insoluble salt. So see you in the next lesson as we discuss action of heat on salts.